Hey guys, BuildZoid here, and today we're going to be taking a look at an old GPU. This is, of course, a GTX 980. So yeah, not anything modern or that relevant, but this is a Zotac Amp Omega Edition card. And a fan of the channel basically has this card, and he was like, "Hey, BuildZoid, you want pictures of this?" And I was like, "Sure," because as far as I know, this is basically Zotac's attempt at doing a like a Kingpin edition or a class of like EVGA has Kingpin edition cards or classifieds, and then Asus has the Matrix series or had the Matrix series. The new Matrix is literally just a Strix with a water cooling gimmick strapped to it, or the Lightning. Which the new Lightning is similar to the Matrix, where it's basically a normal card with, well, actually, no, the Lightning I'd argue is even worse, because the PCB on the new Lightning is not even as nice as it is on the Strix 2080 Ti, but whatever. Or a Hall of Fame from Galax, right? So basically, this is a Zotac's attempt at like an ultra high-end extreme overclocking GTX 980, or at least that's the marketing behind it, because well, everybody would like to have their own ultra high-end, like Halo card like that. Not everybody's capable of building one, and not everybody actually wants to build one, which I'd say is the argument here, because as far as I know, this card was not cheap. So let's get into it, shall we? Starting off with the VRMs. So the Vcore VRM, there's nothing really weird going on with it. I mean, technically speaking, there's nothing weird going on with the memory VRM, except that there's something weird going on with something else. But well, I can't highlight it, because if I highlight it, it's going to be obvious what I'm talking about. Anyway, so this right here is our Vcore, is the Vcore VRM on this card, and that's just a nice 1, 2, 3, 4, 5, 6, 7, 8 phase, nice and simple, true 8 phases. We've got ourselves a NCP. And I don't know why I put that so big, NCP 4208. Which is indeed a 8-phase voltage controller, and for some reason I still didn't improve my notes about what kind of features that has, but yeah, it is an 8-phase voltage controller. It's a digital controller, though things like switching frequency are still set by an external resistor, so it's not fully configurable, but you can change things like the load line calibration, the voltage, and a few other settings through the I2C interface for this controller. So that's what's going on with that. So it's not terrible, but at the same time, it's not like, say, a International Rectifier 3595 or a CHL 8228G or a CHL 8318. That was the one that was really popular for, I think, 900 series NVIDIA cards. Definitely 700 series NVIDIA was like 8318s everywhere, so I assume it was the same for the 900 series. But anyway, so that's the controller, and yeah, we do get a real 8-phase, so that's pretty okay. And then we look at the memory VRM, and the thing about the memory VRM is that it's that. Because, see, Zotac, instead of building a 3-phase memory VRM, right, they did what everybody else does, and they made something that looks like it might maybe be a 3-phase memory VRM, but it's a 2-phase. So the phase split is like so, and basically you have 2 high-side MOSFETs, which I think is like 2 high-side, low-side, low-side. I think it's like that. So they have the power plane going like this, and then there's your output of the inductor. That's the most sensible arrangement for that one. And on this one, I think it's high side, low side, low side, because the 12-volt power plane here goes kind of like that, or at least I think it goes kind of like that. That would make sense to me, but it could be another, like they could also do a U like that. It doesn't really matter. But basically, yeah, so they have 4 MOSFETs in each of the memory phases. So that's what's going on with that. And now you might be wondering, so what the hell is this inductor doing here? Is it a regulator? Well, no, because do notice this shunt here, right? So, and if we zoom out, you'll notice that there's no shunt down there. So what's basically going on, but we do have our shunts for the inputs. So basically, these are our input filters. So 12 volts comes in, it goes through our shunt resistor where it gets measured, then it goes through our input filtering inductor so that the switching noise from your VRM doesn't go outside of you don't have as much switching noise from the VRM going down the power cables. And the same thing for your other 8-pin, right? You have your input filtering inductor over there. And then for memory, we have our input filtering inductor over here. That's what's going on with that. So basically Zotac decided, okay, well, we're not going to build a real 3-phase memory VRM, but what we will do is we're going to take the 12-volt input filter for the PCIe slot, which would normally be located somewhere right here if you were a normal GPU manufacturer, and we'll just put it right in such a position that it looks like it might be part of the memory VRM, but it really isn't. Like, if you look at the back of the card in that area, right? So here's the memory power plane. So, well, you can kind of make it out, right? But, so that's our memory power plane. Here's phase 1. Here's phase 2, kind of, somewhat going on like that. And I was right, because, wait, because that seems to, nah. But anyway, here we have one of the phases. But you can also see that here's our other inductor, and that's a little island. And then this goes into, oh, you know, the plus 12-volt capacitors over here. So yeah, that's great. That's really great that, you know, they're using the 8-put. Like, this could have literally been just like down here somewhere. It could have been a significantly smaller inductor, a probably cheaper inductor, but no, then it wouldn't look like we have 3-phase memory power. So they decided to put the put the 12-volt input filter. Like, it's not an extra part. Like, it's a part that you normally have. It's just like, it doesn't make sense where they decided to put. Well, it does. It practically where it's located doesn't actually do anything. They've literally done it just so that the memory VRM looks more substantial than it really is. We also have these silly capacitor covers for what I assume there's going to be pro analyzers under them. So yeah. But in terms of the output filtering, I'm actually a fan of all the aluminum polymers that they just have bloody everywhere. So that's pretty cool. So, you know, these are still aluminum polymers. Well, I'd assume they're aluminum polymers because tantalums are generally more expensive, and you can get both in this type of packaging. And then, of course, we have multi-layer ceramics just everywhere. So, yeah, I'm a pretty big fan of what they're doing with the output filtering, but when it comes to the VRMs, I'm really not impressed. So, yeah, that's memory. And the controller for the memory VRM, I don't know what it is, but I'm going to assume it's like a UPI 1600 series. So, because that's the normal 2-phase memory power for most NVIDIA cards these days. So that's what's going on with that. And for the MOSFETs in the memory VRM, we're just looking at a bunch of QM, that's not a Q, QM3054s from Ubix Semiconductor. So that's perfectly good. Like, that's fine. There's plenty of high-end cards that use this for their memory power because it's memory power. It doesn't really need to be anywhere near as substantial as the Vcore VRM. Now, in the Vcore VRM department, that's where we get the other sort of haha gotcha, right, from Zotac, where it's like, yeah, we got a nice number of phases. They're actually real. There's no doublers or any kind of weird... like multiple phases, multiple power stages on a single PWM line kind of thing going on. Nothing like that. But the power stages actually just kind of suck. So, you know, that's the solution to, so basically the power stages here are NCP 5369, 69s. And they are DRMOS components, but they also integrate OTP, so over temperature protection. But they're only 35 amps. Like, and unfortunately, their datasheet doesn't include any performance curves, but basically it does mention up to 35 amps of current output. So, yeah, I mean, I assume this is still better than what you'd get on a reference GTX 980, but that's not saying much because NVIDIA's build quality up until, like, the 10 series for their reference cards is terrible. Actually, even the GTX 1080's reference PCB is still terrible. Like, but up until the 1080 Ti, like, reference NVIDIA cards are some of the worst built cards you could possibly buy. Like, it's funny, on AMD's side, a lot of their add-in board partners will often make, like, down-costed versions of their PCBs where they'll downgrade them even further than what AMD puts out. But on the NVIDIA side, if you try to build something worse than what NVIDIA is already putting out, it's probably not going to run at all. Like, it's going to catch fire if you try to do anything like that. So... yeah, you know, it's not like Zotac has to... It's not a very high bar to be better than reference on the NVIDIA side, because pretty much anything is going to be better than reference, assuming it still functions after you run something like any kind of intense 3D load on it. But yeah, I'm really not a fan of the 35 amp power stages here, because this card, like, you know, it's supposed to be like an extreme overclocking LN2 card. So this is going up against the GTX 980 Classified from EVGA, which has the EVGA standard issue 14 phase that they originally designed for the GTX 580 Classified. And then they continued using that same 14 phase for like every single classified card up until like the GTX 1080. You get the same VRM, roughly. Different controllers, and I think they sometimes redesign the output filtering, but the actual like fundamental like MOSFETs and phase count doesn't change. It's always the same thing, and it's always ridiculous overkill. And then, you know, you have Asus, who did a GTX 980 Matrix, which had a 12 phase with 40 amp dual NFETs. So that's more phases and better phases, right? 40 amp phases, 12 of them instead of 8 phases, 35 amps each. Then you have, I'm not sure MSI did anything special for the 980, but Galax did a Hall of Fame 980, and if I'm not mistaken, that one's using 60 amp power stages from International Rectifier, so that's an 8-phase Vcore as well. So that one's like the most comparable, but again, it's like the power stages are almost twice as powerful, so it's like this just generally sucks, right? Like, and unfortunately, Zotac is like, I hate to say this, but they're like the perfect example of being really good at producing cards that just like at a glance they look relatively impressive, and then you start digging into the actual part numbers and it's just like, so like they did the GTX 1080 Ti Amp Extreme, I think it was, where like technically it has a 16 phase Vcore VRM, just every single one of those phases is significantly worse than any one phase on any other custom card. Because they basically decided, yes, we'll have a lot of phases, and then to make sure that we don't spend too much, you know, building an actual nice VRM, we're just going to use the cheapest MOSFETs we could dig up to put into each phase. And the end result is that they managed to build a 16 phase that is less efficient than like the 10 phase and 12 phase designs that a lot of the other board partners have for their 1080 Ti's. And it's just like, well, see, that's why you don't do that. But yeah, so this card is just another example of it, except it's not as extreme, though 35 amp power stages are really not great. And also for a GTX 980, this might actually be fine in terms of power handling capability. It's just that it's not very, like still, it's, if you were choosing between this card and a Classified and a Hall of Fame and a Matrix and a, like, literally all the other custom cards out there, right? Like, why would you get this instead of the Matrix or the Classified or the Hall of Fame or the, I think there was a GTX 980 Kingpin edition as well. So why would you get this instead of any of those when this is like, it doesn't do anything the others don't, and this one's significantly worse in every way, especially in the VRM department. So anyway, now the data sheet for these does not have any performance curves, but that doesn't allow, that just isn't okay with me. So I went and dug up a different 35 amp DRMOS part from On Semiconductor, right? Because NCP, that's an On Semiconductor part number. So I dug up another controller, like another power stage from them that's also rated for 35 amps, and I'm using the efficiency curves for that one instead because it should be relatively comparable considering that it's a 35 amp part, but it might be more efficient at a higher frequency than these, because these, I assume these are significantly older than what I dug up, and generally what you'll notice with older power stages is that they have much worse efficiency at high switching frequencies than the newer stuff, because as with the newer power stages, you basically have faster switching MOSFETs in them. That's kind of the main difference that you get with them a lot of the time. Anyway, so 1.2 volts output and 500 kilohertz switching frequency. This VRM is going to be doing 120 amps output at about 15 watts of heat output, which like that's not exactly hot, right? And if you have a heatsink on the VRM, it'll be handled just fine. But this, I think, is around stock power consumption for a GTX 980. Now, if you go up to 160 amps output, you're going to be looking at about 22 watts of heat, which, like, again, it's not uncoolable. It's just that there are cards out there that, you know, they have VRMs so substantial that arguably you'd be better off turning like a good chunk of them off for max efficiency. And so, yeah, 160 amps output. So, like, air-cooled overclocking or water-cooled overclocking, this card really won't have a problem. It's just that you could have a Classified, right? Like you could get a Classified instead. Anyway, 200 amps output. At this point, it's going to be kicking out 31 watts of heat. And this is where it's like, okay, you know what? Even with the VRM heatsink, you're going to need to probably put a fan over it if you're, benchmarking. Oops, going to grab my orange. There we go. And then if we go up to 240 amps output, which is where the datasheet stops, unfortunately. I know they're rated like 35 amps, but the datasheet stops at just 30. So yeah, can't go past that. About 43 watts of heat. And this is actually legitimately quite hot. And I'd assume that considering this trend, right, like what do we have? We have +7, then here we have +15, and then from 37 to, that's actually only +6. So that's kind of interesting. And it is always 40 amp steps, yeah. So I'd assume at this point it would hit about 50 watt. Oh, wait, I misread my notes. It's 30 watt. I missed that there's no cross on that. That's a 31. Whatever. So it's oops. Well, whatever. So +7 there. Plus idiot there. So +7 plus what is it? That's 1. That's a 1. There we go. Much better. So 22, that's +9. And then from 31 to, yeah, that's +12. So yeah, at this point, if it just keeps going even linearly, which it won't, because typically your heat dissipation on a power stage goes like that. But let's assume it did go linearly. If we do another +12 for the next 40 amps, it's going to be putting out 55 watts of heat. It's going to be pretty damn hot, right? Especially for an 8-phase. So yeah, this VRM, like, the thing is, I don't know how much current a GTX 980 on liquid nitrogen would actually pull. And it probably wouldn't be that much because, if you do like 1.5 times 240 amps, that would work out to somewhere around sort of over 300 watts of power consumption, right? So quite a lot. But, yeah, I'm not really, actually it'd be like 360 watts of GPU core power consumption, so... And well, no, because GTX 980s get to like GTX 980s hit like close to 1,000 watts on liquid nitrogen. So 980 Ti's. So I'm not sure what the 980s shouldn't be that much cooler, assuming that that's the case. But anyway, I don't know how much a GTX 980 would pull, but that doesn't like so technically this VR might be okay for a 980, but you could just have a 980 with a significantly better VRM. And that alone already to me is just like, yeah, this card's pretty pointless, because of that. And Zotac did give you things like, voltage read points, and on the back of the card we also get a over temperature disable switch for LN2 overclocking. I'm not sure if that's OTP for the VRM or if that's OTP for the GPU core. I'd assume it's OTP for the GPU core because normally what you run into is sometimes the thermal protections for the GPU core cause the card to like lock up when you're going sub-zero. And yeah, so disabling that, because the temperature sensors bug out when you go really cold, and they think that the card's actually overheating, and they'll put you, like, shut down the card. So I assume that's mostly just to disable the OTP on the GPU core. And then they also have this right here, which that's a little USB connector, which the idea behind that is that you can plug in a USB cable and basically get a bunch of extra monitoring functionality out of the Zotac Firestorm software for this card. But, it's just like there's no dual BIOS on this card, right? And if you went for EVGA classified, you'd get at least 2 BIOSes, if not 3. If you went for the Matrix, I think that one also had 2 BIOSes. If you went for the Hall of Fame, that one almost certainly had 2 BIOSes. Like, this card tries very hard to look like an extreme overclocking card. It is not actually a good extreme overclocking card, right? Like, it checks off the sort of the surface level features, and then it's like the actual implementation is quite awful. And then of course, like, the card's basically just built to look really, it's a great example of just building a card to look really impressive rather than actually be really impressive, right? So yeah, but still an interesting card to look at, and it's not terrible. I mean, for ambient overclocking, for water cooling and that kind of thing, like, it should be perfectly fine. And again, I'm not sure if GTX 980s scale to the same power, like scale in terms of power draw to similarly to the 980 Ti's, because 980 Ti's, they can like quadruple their stock power consumption when you're on liquid nitrogen. And if this quadrupled its power consumption from stock, that would actually be a problem for the Vcore VRM. But if it doesn't, then, you know, the VRM is relatively okay. But the thing is like, I don't get is just like, you can get like, on Semiconductor makes perfectly good 50 amp power stages. Like at the time that this card was produced, you could get perfectly good 50 amp power stages or 60 amp power stages from On Semiconductor. I have no idea, like, if you're building an 8-phase, you wouldn't just use the freaking 50 amp power stage. It's not like this card was cheap as far as I know, right? This was Zotac's flagship GTX 980. This was their most expensive model, and they're building it with literally the cheapest power stages you could, like, you can't get worse than 35 amp parts from On Semiconductor. They literally don't, like, at least not in their, like, power stage families, as far as I can tell. It's just like, that's the lowest current rating you can possibly get. And it's just like, why would you use this on a flagship card? I will never understand. But yeah, I mean, you know, it's not new. It's like everybody wants to have a car. Like that's the thing. Like it's the best. Like, you know, from a marketing perspective, it makes perfect sense. Make a card that looks really impressive. People will buy it, and as long as they don't actually try to run it on liquid nitrogen, they won't have any problems. So they won't realize that they really overpaid for a card that's like, well, this, right? Like, I'd say if, depending on how expensive this was when it released, if this cost as much as a classified, it's way overpriced. If it was anywhere near a classified or a matrix or the Hall of Fame in terms of price point, massively overpriced, because like there's nothing here that makes it particularly special. It's not terrible, but it's really not like some incredible GTX 980 here. So yeah, that's it for the video. Thanks for watching. Thanks to the guy for sending the pictures of this card in. I really hope that you know, you don't mind what I just said about it, because, well, it isn't very good. I kind of feel bad for you that you bought one of these. I'd assume you bought one of these if you have one. And yeah, but still, thanks for the pictures, because I think it was an interesting card to look at. And what else was there? Thanks for watching. Like, share, subscribe. Leave any comments, questions, suggestions down in the comment section below. And if you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. I also have, there's also Teespring if you'd like to buy shirts, stickers, socks. Yeah, there's actual socks on there, posters, that kind of thing. You can find all of that down in the description below, and it does help out with running the channel immensely. So yeah, that would be awesome if you would check those out. Thanks for watching, and goodbye.